Hi there. This is section 4.1, looking at scatter plots and correlation, and I wanted to go over question 9, which is on page 168. So we're actually going to go over 9, 21, 25, and 29. All those problems are related. So first, question 9 gives you a bunch of data and it says construct a scatter plot. Well, I cleverly put all this information in an Excel program. There's X and Y, 1, 2, 3, 4, 5, 2, 2, 3, 4, 4. It's a pretty clean data set. So to make a scatter plot on Excel, insert scatter. There it is. Looks pretty good, doesn't it? Let's add our regression line. So I scrolled through chart layouts. I just kind of jumped ahead to the regression line to see it. Okay, so the first question here says construct a scatter plot. Great, done. There's our scatter plot. And the next question, here it is, says calculate the correlation coefficient. I was looking, it doesn't say to interpret the scatter plot, but in general, when you're looking at something like this, you want to say, well, it looks sort of pretty much like a straight line. It's not a perfect straight line, but it's pretty good and it's positive. So you can see from the scatter plot that that's a pretty reasonably strong relationship and it's positive. So for the next question, it says calculate the correlation coefficient. The way you're going to want to do this question is you're going to want to put the data into your calculator and calculate R. So that's a separate problem, is how to do this on your calculator. If you do this on Excel, you'll see that R squared equals 0.9. That's R squared. So we want to take R, which is equal to the square root. I don't want to get the equation editor, it'll take too long. Square root of R squared, which was 0.9. So the square root there is 0.9486, or if you round up, 87. So that's the answer. The correlation coefficient is 0.9487. Make that red. Again, you're going to want to do this on your calculator. So you're going to want to enter this data into list 1 and list 2 and then calculate R. So again, that's a separate video of how to use the calculator. So there's R, should be 0.9487. Interpret the value of the correlation coefficient. Okay, I'm noticing that this is positive and it's close to 1. So we can notice that R is greater than 0 and close to the number 1, which means it is a strong positive relationship. Thanks, spell check. Strong positive relationship. And you'll notice we saw this on the scatter plot too. You see the strong positive relationship on the scatter plot. All of these things are connected. So what you see on the scatter plot, you should also see in the correlation coefficient R. Strong positive relationship. If the clouds had been going down, the line had been going down, R would have been a negative number. And finally, use the comparison test to determine whether X and Y are correlated using the data and the value R. So, in order to use the comparison test, now we have this R equals 0.9487. So we look at the table in the back of the book, and I cleverly have the table here. This is table G, as in golf, and it shows the critical values for the correlation coefficient n. So you need to know the number of values in your data set. So if we go back to the data set, we see there's 1, 2, 3, 4, 5. Handy. There's n equals 5 in this case. So we go to the table, n equals 5, and you kind of come across, and you note that the critical value is 0.878. 0.878. So if we go back here, we see that the critical value is equal to 0.878. Okay, now we compare R to the critical value. We see that the R, the correlation coefficient, is greater than the critical value. We see that R equal to 0.9487 is greater than 0.878, which is the critical value. You'll notice I'm not getting paid to type. terrible typist. So this means it is significant. Significant. Hooray! So that means that we can conclude that X and Y are correlated. So we conclude over here that X and Y are correlated. Okay, so hopefully that will clarify how to work these problems and make you feel much better about your keyboarding and typing skills.